Alright, welcome to another video here. We're going to be doing sums and differences of radicals. Let's get moving. Alright. Remember polynomials that look like this, where in order to simplify that you had to combine like terms, right? So you take whatever like terms and put them together. So notice the like terms here are 3a and negative 8a. Anything else I can't put together because they're not like terms. The reason why these are like terms is because they share the same exact variable. All right, so I should simplify that and get something like negative 5a plus 4b plus 9. The same way we combine those like terms, I'll show you what we can similarly do with radicals. Notice in this problem right here, notice I have like terms here, so I can combine those. And I have like terms here, so I can combine those, and I can combine those terms, right? So when I combine all of those terms together, I should get something like negative 6x squared, what's that, plus 12x plus 2. I believe that's correct. So that's the whole idea behind combining like terms. In the case with radicals like this, we do it the same exact way. We actually combine like radicals. Now notice what the like radicals are in this case, right? We have 5 times the square root of 2 is a like term with negative 3 times the square root of 2. So those can actually be combined to get 2 times the square root of 2 plus 6 times the square root of 7. Notice with 6 times the square root of 7, we didn't do anything with it because it's not a like term. So we treat radicals just like if they were variables. Another example is, we'll go through this one, 4 times the square root of 3 plus 8 times the cube root of 3 plus 5 times the square root of 3. Notice what the like terms are. We have one like term here and here. This is not a like term. This one right here is not a like term because it's not the square root of 3. It's the cube root of 3. It's not the same thing. So we can combine those two together to actually get 9 times the square root of 3, and we just leave the rest of it alone. So that will just be 8 times the cube root of 3. So, and from there we're done because we've combined our like terms. So let's try this one together to make sure we have the idea down. All right, with this we're looking for our like terms. Now looking at this, we see that we have like terms here, 3 times the square root of 5 with 2 times the square root of 5, right? And we also have the square root of 2 and 3 times the square root of 2. And notice with 4 times the cube root of 2, there's no like terms with that, so we just leave that alone. Now, as we go through it, we combine our like terms. So these like terms, this 3 times, well, actually, nope, not those. We're combining those terms, and we're combining these terms. So if I combine 3 times the square root of 5 and 2 times the square root of 5, I should get 5 times the square root of 5. And the square root of 2, remember here there's, just like if you have x, there's an imaginary 1 in front of it, like that. It's the same thing here. You have just square root of 2, there's a 1 right there. So that means that the square root of 2 plus 3 times the square root of 2 is going to be 4 times the square root of 2. And then we're just left with 4 times the cube root of 2 right here. And that should be our final answer in this case. So what I want to get to with that is, when you're simplifying something like this, look at this problem right here. It looks like this can't be added together. Why? Because they're not like terms. So what we do is we simplify first. And in order to simplify, make sure you factor out a perfect square. All right? So if in fact we're trying to factor out a perfect square, what perfect square do you know that's in 8? And what perfect square do you know that is in 98? In 8, you're going to get 4 as a perfect square inside of 8. So because 4 times 2 is going to give you 8. And in 98, you're going to get 49 because 49 times 2 is 98. So now that I have a perfect square, I have a perfect square here, and I have a perfect square here, I can take those out. I take the 4 out, it becomes a 2. I take the 49 out, it becomes a 7. And I should have 2 times the square root of 2 plus 7 times the square root of 2. Now I can add them because they are of like radicals. So when I add them, I'm going to be left with 9 times the square root of 2. Another example that we'll see is if we have to factor out a perfect cube. Look here, these cannot be combined because they look like they're not like radicals. But if I simplify them, I might be able to. Now here in 81, I'm not taking out a perfect square. I'm taking out a perfect cube. What perfect cube is inside of 81? The same thing with 24. What perfect cube is inside of 24? In 81, we get 27, and in 24, we get 8. So when we take 27 out of a cube root, it becomes 3. And when we take an 8 out of a cubed root, it becomes a 2. So we should get 3 times the cube root of 3 minus 2 times the cube root of 3. Now they can be combined because they have like radicals. So if that's the case, we should just get good old cube root of 3. So that's how we actually simplify on that. So with those two examples, what I want you to do is I want you to pause the video and I want you to try this one on your own. So pause the video right now, and then when you replay it, you'll see what I get and you can compare your answers. And go. I hope this is what you guys got. Notice what I can break both of those up. I need to take a perfect square out of 27. I can take a 9. Out of 12, I can get a 4. Out of 75, I can get 25. When I do that, 9 times 3 here, 4 times 3 here, 25 times 3 here. When I take a 9 out, it became a 3. When I took a 4 out, it became a 2. When I took a 25 out, it became a 5. Now all of them are like terms. So when I do 3 plus 2, I can do 3 plus 2 minus 5. And when I combine all those, I should get 0 as my value. So that's how we'll be simplifying radicals. That's all I'm going to do for this video. So I hope you enjoyed it or whatever.